All right, so now we're doing interior angles. So rather than setting up within the boundaries of triangle ABC, we are going to be setting up over the tack at A, the tack at B, and the tack at C. Um, I think that I did this in my video. I tried to get a picture through the eyepiece. I'll try to post a better picture of that. But it is kind of a skill to kind of figure out how to actually place it over the tack. It takes a lot of time. Usually everyone kind of is there. So we're not going to be doing that next week with the total stations. You just don't want to kind of save everyone the headache. Marcine, I don't know if you can attest to the the fun of setting up over a point. Ah, well, maybe Marcine is still on break. But anyways, when she's back, she can let you know. It's super fun. When I say super fun, I mean super not. All right. So
Sorry, I'm here. What's up?
oh, I was just saying, setting up over a point. If you could attest to the amount of time and effort it takes to actually get your instrument over a tack.
It is a lot of it's a skill that you really have to learn. And luckily there's usually one person in your group who just has an odd skill for that.
Yeah. Or sometimes there will be somebody in the class that's already done some surveying. And it's amazing because they can just kind of like eyeball it and they just get it right the first time. You're like, what the heck?
It's crazy.
How did you do that? So we're not going to do that next week because it's just a lot of time, and it's a lot of people touching the equipment. And we're trying to minimize all that. But it's really the exact same procedure as what we did before, um, except for now we do have an allowable closure. So again, I'm not going to grade you on whether or not you hit the closure. I'm giving you the data. The important thing is to check it. So we've already went through the setup at A. So let's now go to our setup at B. So we set up our theodolite above the tack at B. And what we're going to do is we're going to cite point C. And we're going to make our lives easier by setting our initial reading to 0. And we're going to unlock that top plate and turn an angle to A. That angle is 16 degrees, 37 minutes, and 40 seconds. And as we know now, this is a very iterative procedure. Lock that top plate, unlock the bottom plate, turn back to C, sight in the tack, lock that bottom plate, unlock the top plate, turn that angle again. And that angle back to A is 31. Oh no, that's wrong. 33 degrees, 13 minutes, and 20 seconds. So if someone could calculate now the average interior angle between C and A. 163640 exactly. Great. So that's that. That measurement would normally take probably about 45 minutes. All the setup, turning, turning back, all that. Realizing that somebody hit the tripod, messed things up. You're not actually over the point anymore. It's a fiasco. So we pick up our instrument and now move it to monument C. And we're going to sight point A. And we're going to turn an angle to B. Now at A, starting at 0, and we're going to turn all the way to B. So this is a kind of a good sanity check. We should be getting an angle larger than 90 degrees. It should be an obtuse angle. And the angle that we turned is 132, 23, 40. And we follow that same procedure of locking, unlocking, turning, locking, unlocking. And we come in for our double angle. And at double angle, 264, 47, 40. So what is the average interior angle? One 132.2350. Does anybody else want to give a confirmation on that angle? One 132.2350. All right, Mason, you said 53. Maybe you have a carrying error in there. We can check in on that calculation later if you'd like. But yeah, that's at 132, 2350. Oh, you're using the calculator? Yeah, maybe let's go over the math then afterwards. You can always refer to that first example problem in the recordings as well. So 132, 23, 50. Oh, all good.
I'm
Cool.
sorry, shouldn't there be 20 seconds left because 40 divided by 2 is 20 seconds. Shouldn't we have the 20 seconds in the end? No?
Let me check.
It should be 20 seconds and then 46, 23 minutes. Yeah. I think it's just the last one. It's not quite right.
All right, let's go through the math.
Oh, you know what? Never mind. I don't want to confuse anybody. I think I got it. Why I was getting it wrong. Sorry.
Are you sure?
Yeah.
I'm happy to go through the math.
No. I think it's okay.
Okay.
I don't want to slow down anybody.
Oh, no worries. We can also we can do a whole math thing after we get all the data as well. So, that's we can definitely do that afterwards.
Okay. Sorry.
Yeah. So, in any case, here are our interior angles. And now we need to do a summation of those interior angles because the sum of interior angles of a triangle should be 180 degrees. So I'm going to give you all a few minutes to sum the interior angles. And then if everyone could just type into the chat the value that they get for the sum of those interior angles that were measured. All right. Kenny is getting 180 degrees, 0 minutes and 40 seconds. Do we have anyone else that same good? Yeah, this one's nice. When I took the angles for this one, I took them to the nearest 20 because that is what the machine can reasonably read to, so it kind of makes the math a little easier there. So 180 degrees, 0 minutes, 40 seconds. So our closure in that case is 40 seconds. And our allowed closure is, I think this was an error in the recordings perhaps, but it's just 1 minute times the square root of n. So that n is not actually seconds, you actually are multiplying by that. And we did this calculation in the previous video. That closure, allowed closure, is equal to 1 minute and 44 seconds. And that is greater than 40 seconds. So we're good. One last thing that we need to do here, we're going to adjust those interior angles. We're going to just evenly distribute the angular measure for all of these angles. So if our closure is 40 minutes and we had 3 angles, sorry, not 40 minutes, 40 seconds, 40, and we have 3 angles, that means that how many seconds per angle are we off?
Thirteen.
13. The closure 40, which is 13 seconds per angle.
I'm sorry, I kind of assumed that it should be proportional to the size of the angle. Don't we do that? We just divide by the number of the angles here?
You could do it that way. So distribution of error is a surveying technique in and of itself. There's like 10 different ways you can distribute error. We're just doing it this way. So yeah, you could do it in proportion to the size of the angle. Some people do it in proportion to the distances. There's all sorts of like statistics. So when you do that, you're getting into statistical techniques, and that's not really what we're focusing on. But yeah, no, you could absolutely use other methodologies for distributing that error. So if we're 13 degrees per angle off and our sum of interior angles was 180 and 40 seconds, that means that we need to subtract off that 13 degrees per angle. And as Olga mentioned, we could do this as a proportionality based on the size of the angles. In this case, we're just gonna lop it off each one. So the first one, 31 degrees, 0 minutes, 10 seconds. We're going to subtract 13 seconds from that. And our adjusted interior angle will be what? $30, $59, $57. So we will report both the mathematical answer and below that, we're going to round to the appropriate precision. So that would be 31 degrees, 0 minutes, 0 seconds, just so we have both numbers reported. All right, what about angle B? $16 degrees, 36 minutes. How many seconds? 27. So our rounded is just below that. And then finally, angle C. Oops, not 16. 132. 23, 37. So 132, 23, 40. In this way, we have both our mathematical adjusted interior angle as well as reporting the correctly rounded number. Now, one last thing, if we adjusted the interior angles, what should our closure be now? 0, exactly. So let's just do that. Let's add up those adjusted interior angles and add the sum. So what's the sum of those interior angles? So I'm getting 180 degrees, 0 minutes, 1 second. Minus 180. So we have a 1 minute error. I think that based on what Kenny, you put something in the chat earlier, I think that maybe you kind of saw where this was going. Why did we get that 1 minute error?
1 second.
Oh, yeah, sorry, I keep messing that up today. This is really not great. 1 second, thank you. Man, I'm really just screwing that up. It's degrees, then minutes, then seconds. 1 second error. Why did we get that 1 second error even after adjusting the interior angles?
Because when we divided evenly by 13, that left 1 second to make up to the 40.
Yeah, exactly. So we said 13 seconds per angle, but really it's 13.33333. So we're left with a dangling second. That's fine. Just make sure, a little note when you have errors like this. Always fine to have little errors or little rounding things. Just write a little note. Due to rounding. Excellent. And that's it. That is our interior angles lab. Let me just zoom in here. So that way when I post the video, you can zoom in on the data if you want to look at it again. That is the completed data page. And then on our details page, please fill that in with the appropriate aspects. And I think that's it. I have one fun extra credit activity. It's not really an extra credit activity. It kind of is. So for everyone watching my beautifully produced videos, highest production quality, I do one thing incredibly wrong every single week. And you are not allowed to do this next week. Anybody know what it is?
You're not wearing a mask?
Well, that's one, but I'm only making the videos with people that I am already within a pod of. So, but it's similar. It's all in the same vein. I am making a major faux pas with my safety, which is I'm wearing sandals in all of my videos. So next week, everyone, don't wear sandals. You must wear closed-toed shoes. One of the facilities I work at is pretty relaxed about literally all of their safety standards, which is kind of scary. But the one thing that they will go on your case about is closed-toed shoes. So please wear closed-toed shoes. I know that a tennis shoe isn't going to save your life, but it is better than nothing. So next week or the week after, depending on whatever lab you're coming to, closed-toed shoes. Bring your own water. Ooh, this is a good point. I need to check in with Joanne about access to bathrooms. But bring your own water. It looks like I looked at the weather. It looks like it's gonna be pretty warm. So bring some water. Bring layers. It looks like classic typical Aptos. It could be low 50s in the morning. Might even get up into low 80s in the afternoon. So layers, closed-toed shoes, water, and a snack. Yeah, heels up, hats, sunscreen, absolutely. Hats are great. I think I learned the lesson like my first week out that if you're going to be standing outside, hats are a must. Yeah, thanks, Kenny. Hat, sunscreen, sunglasses. Yeah, that's it. So please stick around if you have any questions, go over any calculations. Otherwise, I'm going to stop the recording. I will get these posted by, I'll do better than last week. I promise that I will get these things posted within the next hour and a half, as long as I get the recordings. But otherwise, I'm going to stop the recording now and TTFN.